Hello everyone, welcome back to HUB360 Circuit, your go-to channel for electronics tutorials, embedded systems, and practical projects. In this video, we'll be learning about RFID technology and working with two popular RFID reader modules used with Arduino, the RDM6300 and the RC522. We'll explain how RFID works, how each module communicates with Arduino, go through the actual Arduino codes and show you where and how these modules are used in real-life projects like access control, attendance system, and security applications. So if you are just getting started with the RFID or trying to decide which module is best for your project, this video is for you. For the RDM6300, part of this project, we need Arduino Nano RDM6300 RFID reader module, 125 kHz RFID card, jumper wires. The RDM6300 is a low-cost 125 kHz RFID reader module. It's commonly used in door access control system, attendance and time logging system, simple security projects. One of its biggest advantages is that it uses serial communication (UART), which makes it very easy to interface with Arduino, especially for beginners. Now let's connect the RDM6300 to the Arduino. The RDM6300 module has 4 pins: VCC, ground, TX, and TX. The RX to your digital pin 2, your RX to your digital pin 3, your TX to digital pin 2. Once the wiring is done correctly, your RDM6300 is ready to communicate with Arduino using serial communication. Now let's connect the RC522 module to the Arduino. The RC522 uses SPI communication and works at 3.3 volts, so be very careful with power. Your VCC, which is 3.3 volts to 3.3 volts on your Arduino. Your ground, RST to digital pin 9 on your Arduino. Your SDA to Arduino digital pin 10, your MOSI to Arduino digital pin 11, your MISO to Arduino digital pin 12, and finally your SCK to Arduino pin 13. You must be very careful when connecting the RC522 to 5 volts. It can permanently damage the module. Do not connect the RC522 to 5 volts. RDM6300, software setup for RDM6300. On the software side, we use software serial because Arduino Uno and Nano have only one hardware serial port, which is already used for USB connection. The default baud rate is 9600. Each card sends a 14-byte We start by including the software serial library, and next we create a software serial object. The pin 2 is connected to the TX pin of the RDM6300. Pin 3 is unused because the module only sends data. We declare a string to store the card ID. In the setup function, we initialize both serial connections. In the loop function, we read incoming data character by character. When the start byte 0x02 is detected, we clear the old tag. When the end byte 0x03 is detected, we know the full UID has been received. When the end byte 0x03 is detected, we know the full UID has been received. We then compare the UID with predefined card IDs. If the UID does not match any known card, it is marked as unknown. Any other character received is added to the tag screen. We begin by including the required libraries. We define the reset and slave select pins. We create an RC522 object. In the setup function, we initialize serial communication and SPI. We initialize the RC522 module. Then we set the antenna gain to maximum for better performance. We print the reader's version information. In the loop function, we check for a new card. If a card is present, we read its UID. So this is the RDM6300 RFID card, and it can only scan 125 kilohertz cards. So each card contains a UID, which is unique identification ID. Each card contains a unique ID. So when you scan, see that the tag ID, the unique ID displays, and the name on the tag also displays. This is because of the code used. That is why you can see that this particular card, the UID is showing Mr. Zach. Now, if I take another card and I scan, you can see the tag ID is different and the name on the tag is Joshua. The name was saved on the code as Joshua. And then this is another card too. When you scan, you could see the tag ID is different and the name showing is HUB360. So every card has a unique ID that is used for the RDM6300 sensor. The RC522 emits a 13.56 MHz electromagnetic field. When a compatible card comes close, usually within the range of 2 to 5 cm, the card is powered by this field and sends its UID. The RC522 then sends this UID to the Arduino using SPI communication. The Arduino processes the UID and decides what action to take. Like you can see here, each RFID card has a unique ID, and when you place it close to the RC522, it reads the UID of the card. This is one of the card, and then this is another card. When you place it, it reads the UID of the card. So, this is another card. So this is. So every RC522 card has a UID that reads when it's placed to the RC522 sensor. If you want something simple and beginner friendly, go with the RDM6300. If you need modern cards, writing compatibility, or IoT integration, the RC522 is the better choice. In this video, you've learned how RFID technology works, the difference between RDM6300 and RC522, how to read RDFID cards using Arduino, how access control logic is implemented in code. If you found this tutorial helpful, like, subscribe and share this video. For quality RFID modules, Arduino boards and electronic components, check out HUB360 Circuit. Thanks for watching. See you in the next tutorial.